Right, hi everybody, it's Graham again from Z-Tech Inside. I've got a little video here to present to you a challenge that I've got in trying to improve the launch control and the traction control on the race car. Now, the car currently has 4 wheel speed sensors, one on each wheel, and as the wheel rotates there's a disc on the wheel. See, this is a front wheel speed disc. This has only got 8 holes in it, and it actually passes by a sensor, and the sensor measures the number of pulses as the disc rotates. Okay, now with only having 8 holes in the sensor, in the trigger disc, it's basically the wheel would travel quite a long way between each pulse. So in order to improve the resolution, the ability of the ECU to react and respond to differences in wheel speeds, I'm going to produce a 3D printed plastic trigger disc. Now, steel discs are all well and good. They're heavy, they're difficult to manufacture with a lot of holes, and the reason being is you normally end up with a circular hole, and you have to have a space between the holes in order to measure the movement of the hole across the sensor. If you wanted to put 20 holes into a disc this size, the holes would be very small and the sensor would have difficulty measuring the gaps between the holes. So in order to get around that problem, I'm going to design a printed trigger disc, and I'm going to use steel dowels which we pushed into the disc, and the trigger will then take place as the steel dowels rotate past the sensor. So that's the plan. My car's one of the fastest cars in the championship off the line. I don't think there's any cars faster than mine launching in the wet. It's a phenomenal system. It's using a Life ECU, which is the same as Cyvex. It's one of the better launch and traction control systems that you can get on the market. And I've spent 3 or 4 years now tuning the system to get it as quick off the line as it is. It does 64 foot in just over 2 seconds, and in the wet it's only a couple of tenths slower than it is in the dry to launch it. It's a great system, but I think we can improve it. And the way I want to improve it is by adding more pulses, providing better resolution so that the ECU's got more information coming back about what speed the wheels are travelling around at, and it can then react a lot faster. And it basically reacts by reducing torque. So if it's sensing wheel speed, it will actually reduce the torque output from the engine, and you can hear that when you're driving. You can actually feel it a small amount, but the system's so good that when I get to the apex of a corner, I can just put my foot flat to the floor and accelerate fully, and the ECU just takes care of everything else. It's quite safe. I did manage to turn traction control off at Pembrey last year because I had a switch setting that I should really have realised it was multiplying traction control by 0, which effectively turned it off, and I planted my foot on the throttle and the car just spun off the track. So you do need traction control with these cars. The EcoBoosts have got such huge amounts of torque that it's almost impossible to drive flat out without launch and traction control working properly. So that's the plan. So the video will take you through the stages of designing a trigger disc in Fusion. I'll then send the file away to 3D People for them to print for me, and when it get back, hopefully when the steel dowels arrive from eBay, I can then just push the dowels into the holes in the disc, and then we can do some testing on the bench, and then once that's proven that it will actually detect the pulses as the sensors detecting the dowels rotating past, then I'll put it on the car, and then we'll try it in the garage, and then I won't really be able to test it on the car fully until the first event, which is at probably testing in Brighton in March, and then we'll see whether it works. And if it works well, which I'm hoping it will, then I'll fit a disc to both front axles. I'm just going to set it to 1 for the time being, and then we'll see how it goes. Right, so stay with me. I will talk you through the rest of the process, and then we'll see how far we get. So opening Fusion 360, I've got a drawing here that I've quickly produced. It's essentially the same circumference as the steel disc, but it's basically made from plastic, and there are 20 holes on the outside, to which in this design here you can see I've already fitted the steel dowels. I just went in and searched for them in the parts finder and added them in. If I just scroll the timeline back, you can see that's what the disc looks like without the steel dowels fitted.
The weight is only, I think, 10 or 15 grams of plastic. It's very, very lightweight. It's considerably lighter than the steel disc, and obviously with the weight of the steel dowels added, it just bring the weight back up a little bit, but it's still nowhere near as heavy as the steel disc. I'm quite pleased with the design. I've put my ztechinside.com writing on it for printing, and when it gets back we'll get it fitted and see if it works. So what we have here is the end product. It's the 3D printed plastic trigger disc with the 20 dowels inserted around the circumference. It was quite easy to produce. The disc took about 2 weeks to have printed. I had a pair of them done, and then I just had to insert all the steel dowels, which just took sort of 5 minutes, just a bit of patience just to push them in. They're a good tight fit, they can't fall out, and I didn't even need to enlarge the holes in the printed disc, thank goodness, they just went straight in. So the next step then is to put it onto the test assembly unit that I've got, and we'll spin it around and we'll see what kind of frequency response we get from it. Right, let's go for a quick spin then. It's recording. Got a little crank handle on it. Keep some fingers on the top, stop it from falling to bits. I did have one that rapidly disassembled itself. Right, let's see how far I get this one then. 1.9 kilohertz. It's pretty good. Yeah, very good. Very pleased with that. So the next step was to fit it to the car, and here you can see it's fitted to the inside of the front near side wheel and spins as I rotate the disc. So we're looking good. A bit more tools. Right, okay, let's try again. Here we go. So, hopefully you can see the screen all right. Here we go. Wow. Well, that's the equivalent of 100 miles an hour. There were no dropouts at all on the pulses that were coming on the display. Everything looks fine. That's good news. So just do it again. Keeping your hands and fingers clear. Here we go. That looks okay. Can't see a problem with that. So I think that's a success then. We have a 3D printed plastic trigger disc with 20 dowels in it, fitted on the car, and I can spin the wheel on the car and the sensor can pick up the movement as the dowels go past the sensor. That's great. I will have to run the steel disc on the opposite side on the front axle, just as a backup in case the plastic one fails for whatever reason. And the ECU is set to take the maximum speed from the front axle, so whichever sensor is still running, if one of them fails, it will still report to me the speed that the car is travelling at. It's a fantastic system. I do hope this is going to improve it. If it does, it works, I will then fit the second plastic trigger disc to the opposite side, so we're running plastic trigger discs on the front on both axles, and then we'll see what it's like at launching and accelerating and coping with the traction events that it does so well at the moment. So thank you very much for watching. I hope you've enjoyed it. Please don't forget to like and subscribe, and I'll be posting more videos soon. Thank you very much.